Hello everyone, welcome to the third lecture of week 5. In the second lecture, we have explored epsilon delta definition of limit and existence of the limit. We saw some problems where we have determined the limit of that functions. In this lectures, we are going to prove that if a function has the limit at a point or near to that point, that means that limit must be unique, and that's why the lecture title is uniqueness of limits and algebra of limits. We will also explore that if two functions has the limit, then their addition, their subtractions has the individual limit or individual sum or subtraction of that limit. We will go to prove analytically with addition, subtraction and product of the limit of two functions, and then we will see some examples for that, right? So thank you, and we will start with algebra of limits here. So uniqueness of limit, we have seen in the sequence where we have seen that if a sequence converges, then it converges uniquely, right? We have seen this one. That means it has the unique converging point or unique limit points. Similarly, function at some point x equal to c or x equal to somewhere, if it exists, then it exists uniquely. How to prove this one? So look at the slides here. So I have to prove that if function fx has the limit at x equal to a, then it is unique. So x equal to a is given here, and I have to prove that any function, if it has here, this is here f of x and this is equal to L, then it is uniquely. There is no other their limit exists for this function. So suppose if possible, it has two limit at the same point x equal to a. So limit x tends to a f x equal to L and limit x tends to a f x equal to L dash exist, right? So our aim is to show that L equal to L dash, because I have to prove the uniqueness. So for any arbitrary epsilon greater than 0, by the definition of the limit, there exists a delta 1 which is a function of epsilon and delta 2 which is a function of epsilon. Both are positive numbers such that fx minus L is less than epsilon by 2 whenever x minus a modulus is less than delta 1 and fx minus L dash is less than epsilon by 2 whenever x minus a is less than delta 2. Now we can define delta as maximum of delta 1 delta 2, right? So this will give me f of x minus L modulus is less than epsilon by 2 whenever x minus a modulus is less than delta, and f of x minus L dash modulus is less than epsilon by 2 whenever x minus a modulus is less than delta. In those two cases, you can have this as making these two cases, this will give you fx minus L modulus is less than epsilon by 2 and f of x minus L dash is less than epsilon by 2 for the same range for x minus a modulus is less than delta. We will use this one for x minus a is less than delta, both inequalities holds, right, by taking this. Okay, so we have to take here not maximum but minimum here. Why? I will show you why we are taking this not maximum but minimum. This is minimum. Why? Because delta 1 and delta 2, if I take delta 1 and delta 2 minimum, then minimum will work, maximum will also work, it does not matter. X minus a, if I take delta, it is always less than delta, but this minimum does not work, right? I mean, it's not necessarily to work here. So the maximum is right here. Here maximum is the right word, right? So here This is not minimum, but take the maximum to have a safer side. So if I have x minus a is less than delta, that means for every delta 1 and delta 2, x minus a modulus is less than delta, that means it must be less than delta 1, and x minus a modulus is less than delta, this must be less than delta 2, right. So that means I have to take the minimum of these two. So in the previous slides, it's not the maximum but the minimum one, right. So sometime you have to determine which one you will took. See here, so the minimum of these two is work. So this is right. And okay, so once you chooses delta as the minimum of delta 1 and delta 2, both valid, and once it valids, then we will calculate L minus L dash. So subtracts and add fx, L minus fx plus fx minus L dash, and then find out this value. So this is less than this and this, these two terms a and b. Why? Because a plus b modulus is less than modulus of a plus modulus of b. So use this one, and this is given epsilon by 2, this is also given epsilon by 2. So L minus L dash is less than epsilon, and since epsilon was arbitrary, so it follows that L minus L dash modulus is going to be 0. So that's why L equal to L dash, right. So limit is unique. Now algebra of limits. So if limits of two functions fx and gx are given as L and M, then their addition limit extends to C fx plus minus gx is equal to the individual one limit fx plus minus limit gx is equal to L plus minus M, and the product limit fx into gx equal to limit fx into limit gx is equal to Lm, and their division limit fx by gx equal to limit fx divided by limit gx is equal to L by M, provided M is not equal to 0 as well as the limit of gx extends to C exists and not equal to 0. That is the true, right. So we can write down here. So we will see the proof of this first one. So first theorem, limit fx equal to L and limit gx equal to M is given, then prove that plus minus fx plus g is the limit of these is equal to the individual of plus minus of this is equal to L plus minus M, right. So for epsilon is greater than 0, by the definition there exists delta 1 which is a function of epsilon, delta 2 which is a function of epsilon, such that fx minus L is less than epsilon by 2 whenever x minus a is less than delta 1, fx minus of L dash is less than epsilon by 2 whenever x minus a is less than delta 2, right. Okay. So taking delta as a minimum of delta 1 and delta 2, and then x minus a is less than delta. So fx plus minus gx can be written as minus of L plus minus of L dash. So for fx plus gx minus L plus of M, here L, this is M, right, and this will become f of x minus of L and plus g of x plus of minus of M, right, modulus. So taking this as a and b, modulus of a plus b is less than modulus of a plus modulus of b. So doing the same thing, fx minus L modulus plus of gx minus M modulus. So this will comes out to be less than epsilon by 2 plus epsilon by 2 is equal to epsilon, right. So that's what we have taken here. This is not L dash but this is M, right. And for negative it has the same value. So, the fx minus L plus of gx minus m will become minus of this modulus, which is less than epsilon by 2 plus epsilon by 2 equal to epsilon. So, this is the easiest one. Now, look at the next theorem, the product of limits, limit fx equal to L and limit gx equal to m. Then prove that limit fx into gx equal to limit fx into limit gx, and limit fx equal to L, limit gx equal to m. So, for epsilon greater than 0 and taking as an arbitrary number, by the definition of the limit, there exists delta 1, which is a function of epsilon, and delta 2 is a function of epsilon, and this will valid by the definition itself. Fx minus L is less than epsilon whenever x minus a is less than delta 1, and gx minus L dash is less than epsilon whenever x minus a is less than delta 2. Taking this as a delta as a minimum of delta 1, delta 2. This will also happen. So, fx minus gx in minus lm. So, we are going to find out fx into gx minus lm modulus. To do this, let we have L into gx minus and plus. So, subtract fx into gx plus of L into gx minus of L into gx minus of Lm, and simplify it. So, what we have done? We have added and subtracted L into gx one term, and then simplify it. So, the first term will become this one. So, taking the gx as a common from this one, from the here and here. So, f of x into g of x minus L into gx plus of L into gx minus of Lm modulus. So, take gx common, it will gives you f of x, right. So, this is f of x minus L modulus, and then minus here, then take into, okay. So, take L into gx minus m. So, you will get gx common into f of x minus L modulus, and then you will get modulus L into modulus of gx minus m. All these modulus gx is equal to modulus gx into fx minus L into modulus L gx minus m. Now, gx can be written as minus plus. So, adding m and subtracting m both sides. So, m plus gx minus m, this is less than modulus of m plus modulus of gx minus m is less than. This will happen because gx is the limit point m. So, this is nothing but this is epsilon. So, this is less than modulus m plus m. So, gx is less than modulus m plus epsilon. From this equation, that means 1, 2, 3, the previous one here, this is the one, right. So, 1, 2, 3, we have fx into gx minus Lm is less than equal to modulus m plus epsilon into epsilon, fx minus gx here, see this one, into epsilon plus of modulus of L into this epsilon, right. Now, this will simplify as modulus m plus modulus L plus 1 into epsilon. So, taking epsilon as a outside, these quantity are fixed quantity. So, I can take this epsilon as epsilon dash divided by m plus L plus 1. And now, after choosing this one, this will become a, what was there was a modulus m plus modulus L plus 1. These were the number, and this can be written as epsilon dash by choosing epsilon as what? Epsilon as chosen, epsilon is equal to epsilon dash divided by modulus m plus modulus L plus of 1, and this number modulus m plus modulus L plus 1. So, this will be cancel out, it will become less than epsilon dash. So, limit x tends to 0 fx into gx equal to Lm. That is the proof. So, we can apply these things in example through the examples. So, first expression you will see, evaluate limit x tends to minus 1, x plus 2, 3x minus 1 divided by x square plus 3x minus 2. Here the terms above is in the product of the two function x plus 2 into 3x minus 1, and in the down one, if I put minus 1, this will be 1, this will be minus 3 and this will be minus 2. So, this will become minus 4. So, I will use the algebra of limit. So, algebra of limit give me the assurance that I can use these x plus 2 into 3x minus 1 divided by x square plus of 3x minus 2 individually. So, limit of x tends to minus 1, x plus 2 into limit x tends to minus 1, 3x minus 1 divided by limit of x tends to minus 1, x square plus of 3x minus 2. Here this will give you 1 and this will give you 3x minus 1 equal to minus 4. So, this will be minus 4 divided by minus 4 is equal to 1. So, the limit of this expression is 1. Similarly, evaluate a square root of 4 plus x minus 2 divided by x. Here x tends to 0, this will not valid. So, we are not going to use this one, we are going to simplify or rationalize this irrational expression in a rational form. How to do this? By taking product of this expression. So, by numerator and denominator we multiply a fixed number square root of 4 plus x, square root of 4 plus x plus 2 by numerator and denominator. It will, the above will become, the numerator will become a square of this. So, this will become 4 plus x and this will become minus 4 divided by how much? Square root of 4 plus x plus of 2 into x, right? That will be answer. So, this will comes out to be 4 cancel out, x divided by x into square root of 4 plus of x and plus of 2. So, x cancel out, take the limit now, limit x tends to 0, 1 divided by a square root of 4 plus x plus of 2. So, this will be 1 divided by a square root of 4 plus of 2 is equal to 1 divided by 2 plus 2 equal to 4. So, 1 divided by 4. So, the limit is 1 by 4. Let me do the again for you. If you have any question or any problem in evaluating this, let me give you some idea of how we can simplify this. So, if I put x equal to 0 here, this expression cannot evaluate it. So, what we have done earlier, we have done to simplify the function in such a form where the factors or the expression become easy and has the limit, right? That is our purpose. So, to do this, limit x tends to 0, square root of 4 plus x minus 2 divided by x. Now, it is an irrational function, so rationalize it. By rationalizing it, you have to divide and multiply by its counterpart, that is root square 4 plus x plus 2, and then it will become very easy to do this. So, this will become limit x tends to 0, 4 plus x minus 4 divided by x into a square root of 4 plus x plus of 2, right. So, this will become limit x tends to 0, 1 divided by, this is x is cancel out, 4 cancel out, and this will comes out to be 4 plus x plus of 2. So, this will be 1 divided by 2 plus 2 equal to 1 by 4. That is our answer. That is our answer. So, evaluate these 6 questions. I will evaluate the first questions. How to evaluate it? So, let us put this value x tends to 0 directly to this one. If I put x tends to 0, this will become 16 divided by 4. So the cancel out and it will comes out to be 4, right. So that means limit x tends to 0, I can write this one x plus 16 divided by 3x plus 4. So this will becomes out to be a square root of limit x plus 16 divided by limit of 3x plus 4, and this will comes out to square root of 16 by 4 equal to square root of 4 equal to 2, right. But what will be the next idea how to evaluate in a different way? We can use this one and we can evaluate the whole thing in a different way. I will give you one suggestion for you. So why not we let this one that this will become as a rational function. So since the whole expression is in the square root, that's why we are not going to rationalize it. We just use the same one. So now look at here. So putting the value t equal to minus 2 does not alter these expressions. So you can put this value directly. So limit t tends to minus 2, 3t square plus of t divided by t minus 3. Put this value directly. It will gives you minus of 2 minus 3 equal to minus of 5 in the denominator, which is valid, which is not 0, that means it's okay. So and the above become 3 into 4 and plus of minus 2. So this will become 12 minus 2 equal to 10 divided by minus 5 equal to minus 2. That will be your answer. Similarly, you can find out all those limits are quite easy to do this. So these are, I think, enough for you to do this. If maybe I can simplify this equation. This equation was very fuzzy. So let me erase first and then we'll give you the idea how we have taken this one. So right, and since we are going to evaluate f of x into g of x minus lm modulus, what we have to do? We have to took in such a way that this expression comes, and this expression is nothing but you will find out gx into L minus fx into g of x into L into g of x minus of m, right. So what these expression are? These expression of Lgx minus fg into Lg minus of Lm. That is the expressions. So once you have the expression, you will find out that taking g as a common, it will comes out L minus f from this one into taking L. So taking L g minus m now, and this will give you mod of g can be written as m plus minus of g minus of m, right, and this is less than equal to m plus of modulus of m plus of epsilon, right. Using this thing, it will comes out a quantity here modulus m plus epsilon plus modulus m. So this will comes out to be modulus of m plus of modulus of L plus of 1 into epsilon. Now take epsilon dash in such a way that it will come epsilon dash. So epsilon divided by if I taking epsilon dash divided by this quantity, it will comes out epsilon dash. That is the idea. So thank you so much.